Hello, we are going to start with the 7.8 known by the name improper integrals. And before starting, let me share my screen. Yes, improper integrals. Integral a to b fx dx is said to be an improper integral if either a is equal to plus or minus infinity or b is equal to plus or minus infinity or fx has a vertical asymptote in the interval ab. That is, it has a vertical asymptote between a and b. And an improper integral is said to be convergent if its value is finite and divergent if its value is plus or minus infinity. For example, you consider the integral 1 to infinity 1 over x square dx. This is an improper integral because one of the limits is infinity. So that is equal to integral 1 to infinity x to the power of negative 2, 1 over x square is x to the negative 2 dx. Apply the power rule, that is x to the power of negative 2 plus 1 over negative 2 plus 1, that is x to the negative 1 over negative 1, 1 to infinity, that is negative 1 over x from 1 to infinity. Substitute the limit. When you substitute the upper limit, you get negative 1 over infinity minus lower limit negative 1 over 1, and 1 over infinity is 0, plus 2 negatives makes a plus, plus 1. So the answer is 0 plus 1, which is equal to 1. Now you consider, so that means this improper integral is convergent and it converges to 1. Value is 1. Second example, integral 1 over x dx, same limit, integral 1 to infinity 1 over x dx. And the derivative of 1 over x is natural log of x. So it is natural log of x from 1 to infinity, that is natural log of infinity minus natural log of 1, that is natural log of infinity is infinity, and so infinity minus 0, natural log of 1 is 0, infinity minus 0 is infinity. So the integral is divergent. Now one more example. Integral negative 1 to 1, 1 over x squared dx. This is actually a misleading question. I will tell the reason in a minute. So negative 1 to 1, 1 over x squared dx is equal to integral negative 1 to 1 x to the negative 2 dx, that is x to the negative 1 over negative 1, from negative 1 to 1, that is negative 1 over x, from negative 1 to 1, and that is negative 1 over 1 minus negative 1 over negative 1, that is negative 1 minus 3 negatives makes a minus, negative 1 minus 1, negative 2. But this answer is wrong because this is an improper integral since there is a vertical asymptote between negative 1 and 1. That is the vertical asymptote at x is equal to 1. See, if you draw your graph by using your calculator, you get a graph like this. So that means there is a vertical asymptote. So what you have to do is you split the integral from negative 1 to 0, 1 over x squared dx, plus 0 to 1, 1 over x squared dx. Let us evaluate one of them. The second one, integral 0 to 1, 1 over x squared dx is integral 0 to 1 x to the negative 2 dx. that is x to the negative 1 over negative 1, that is equal to negative 1 over x from 0 to infinity, that is negative 1 over 1 minus negative 1 over 0. So there are two negatives. It becomes negative 1 plus infinity 1 over 0 plus, because this is x lies between 0 and 1. So it is 0 plus. So negative 1 plus infinity is infinity. So that one branch is infinity. Definitely that whole thing is divergent. So negative 1 to 1, 1 over x squared dx is divergent. So the moral of the story is, when you get an integral or a definite integral, make sure that there is no vertical asymptote in between those two numbers. If there is a vertical asymptote, then you have to split it into two and evaluate both of them. If both of them are finite, then the answer is the sum. Okay, so now there comes a very important test for convergence. This is known by the name the p-test. Integral 1 to infinity 1 over x to the p is convergent if p is greater than 1 and divergent if p is less than or equal to 1. If p is 1, it is divergent. If p is anything less than 1, it is divergent. But if p is greater than 1, it is convergent. So this is known by the name the p-test. Then there comes a comparison test. Suppose that you have two functions fx and gx such that gx is positive, 0 less than or equal to gx less than or equal to fx. That means gx is less than fx or fx is greater than or equal to fx. If integral a to infinity fx is convergent, then integral a to infinity gx is convergent. See, this is another symbol that tells you convergent. So if integral a to infinity fx dx is convergent, then integral a to infinity gx dx is convergent. Remember, gx is less than or equal to infinity. On the other hand, if integral a to infinity gx dx is divergent, then integral a to infinity fx dx is divergent, because fx is more than gx. So this is the comparison test. Now let us work out the problems here. Evaluate integral 0 to infinity 1 over 4th root of 1 plus x. Fourth root of 1 over 4th root of 1 plus x is x 1 plus x or x plus 1 whole to the power of negative 1/4. Apply the power rule. X plus 1 whole to the power of negative 1/4 plus 1, that is 3/4, divided by 3/4 from 0 to infinity, that is 4/3. Division by 3/4 is the same as multiplication by 4/3, that is 4/3 times infinity plus 1 to the 3/4 minus 1, that is infinity. Infinity plus 1 is infinity, that to the power of any positive number is infinity. So the integral is divergent. Number 8 from the text. Integral 1 to infinity 2x plus 1 whole to the 3 dx. One over 2x plus 1 to the power of 3 is the same as 2x plus 1 to the power of negative 3. And apply the power rule and the extension of the chain rule. So this is 2x plus 1 whole to the negative 3 plus 1, that's negative 2, divided by negative 2. Multiply that by 1/2, because there is a number, coefficient number 2. So you have to divide by 2 or multiply by 1/2. That is equal to negative 1/4, 2 times negative 2, negative 1/4 times 1 over 2x plus 1, the whole square, plus from 1 to infinity. When you substitute the upper limit, you get negative 1/4 times infinity square in the denominator, because 2 times infinity plus 1 is infinity, minus negative 1/4 times 1 over 2 plus 1, 2 times 1 is 2, 2 plus 1 is 3. So that is 1/4 times 1 over 3 square. So that is equal to, this part is 0 because there is an infinity in the denominator. And this is 2 negatives makes a positive. 9 fours are 36. So the final answer is 1 over 36. So it is convergent. Number 14, integral 1 to infinity e to the negative 1 over x square. You have a 1 over x and a 1 x square in the denominator. So you do a substitution. Negative 1 over x is equal to u. Differentiate both sides with respect to x. You get negative. Negative 1 over x squared is the derivative of 1 over x. Dx is equal to du. That is 1 over x squared dx is equal to du. So this 1 over dx over x square, that is 1 over x square dx is du. So it is going to be e to the u du. X varies from 1 to infinity. That is, under derivative of e to the u is e to the u. X varies from 1 to infinity. U is negative 1 over x. So this is e to the negative 1 over x from 1 to infinity. And so that is, substitute the upper limit, e to the negative 1 over infinity minus e to the negative 1 over 1. 1 over infinity is 0. So that is e to the 0 minus 1 over e. So that is e to the 0 is 1. Final answer is 1 minus 1 over e. Number 18. Integral 2 to infinity 1 over u square plus 2u minus 3. You do the partial fraction decomposition here. We will come back to this in a minute. 1 over u square plus 2u minus 3 is equal to 1 over u plus 3 times u minus 1. Minus 3 plus 2, yeah. So that is a over u plus 3 plus b over u minus 1. Multiply by the LCD, namely u plus 3 times u minus 1. So you get u plus 3 and u minus 1 cancels in the left. You get 1 in the left. A times u minus 1 plus b times u plus 3. Distribute. That is au minus a plus bu plus 3b. That is combined like terms. 0u plus 1 is in the left side. Au plus bu is a plus b times u plus negative a plus 3b. And compare the terms. A plus b is equal to the coefficient of u, which is 0. And negative a plus 3b is equal to 1. You add these two so that a cancels. So a cancels, 3b plus b, that's 4b is equal to 1. Means b is equal to 1/4. A plus b is 0 means a is negative b, that's negative 1/4. So that expression is equal to negative 1/4 over u plus 3 plus 1/4 over u minus 1, because a is negative 1/4. So negative 1/4 over u plus 3 plus 1/4 over u minus 1, that is equal to negative 1/4 times natural log of u plus 3 plus 1/4 times natural log of u minus 1. I did not write the absolute value sign. Do you know why? Because u is positive, 2 to infinity. So that is, u is above 2 means u minus 1 is positive always. So you don't have to write the absolute value sign. So that is equal to 1/4 times natural log of u minus 1 over u plus 3, because first term is negative. And that is equal to 1/4 times natural log of 1 minus 1 over u divided by 1 plus 3 over u. The reason is we are going to substitute infinity here. If you substitute infinity directly, you get infinity over infinity is not necessarily 1. So you have to find the limit by dividing each term by a u. So that becomes u minus 1 over, 1 minus 1 over u divided by 1 plus 3 over u. So 1 minus 1 over u divided by 1 plus 3 over u. Now, limit is from 2 to infinity. Substitute infinity first. When you substitute infinity, 1 over infinity is 0, 3 over infinity is 0. So natural log of 1 over 1, natural log of 1 minus 1/4 times natural log of, you substitute u is equal to 2 and simplify, you get 1 over 5. So 1 minus 1 over 2. So you may use the calculator and see it. 1 minus 1 over 2 divided by 1 plus 3 over 2, which is 0.2. 0.2 is the same as 1/5. So that is negative 1/4 times natural log of 1/5. Natural log of 1/5 is natural log of 1 minus natural log of 5. Natural log of 1 is 0. So that is negative 1/4 times negative natural log of 5. The answer is 1/4 times natural log of 5. So it was convergent. Question number 22. Integral 1 to infinity natural log of x divided by x square. Let us do a substitution. U is equal to natural log of x. So x is equal to natural log of, x is equal to e to the power of u. Dx is equal to e to the power of u du. Replace natural log of x is u. Dx is e to the u du. X square is e to the u the whole square, because x is e to the u. And among the e to the u and e to the u the whole square, one of them cancels. So that is equal to u divided by e to the u. That's the same as u times e to the negative u du. Now you do the integration by parts. I applied the tabular method. First function is f is u. Its derivative is 1. Its derivative is 0. Second function g prime is e to the negative u. Its antiderivative is negative e to the negative u. Its antiderivative is e to the negative u. Change the middle sign and multiply. So it is negative u e to the negative u minus e to the negative u, where x varies from 1 to infinity. Now you replace u. Negative u, that's natural log of x, e to the negative natural log of x minus e to the negative natural log of x, and that is negative natural log of x times 1 over x. This is e to the natural log of x to the negative 1. That is x to the negative 1, which is 1 over x. Negative natural log of x times 1 over x minus 1 over x. And now you have to apply the limit here. When you substitute infinity, you are getting infinity over infinity. So you use the L'Hopital's rule here. That is equal to limit x approaches infinity. Natural log of x derivative is 1 over x. X derivative is 1. When you plug in infinity, it is 1 over infinity. So this part is infinity minus 0, that is 1 over infinity, that is 0. So that is negative infinity 0 minus 0, which is 0. Minus, when you substitute the limit, lower limit, you get natural log of 1 is 0. So that part is 0. Minus 1 over 1, that is 2 negatives makes a positive. So that is answer is 1. So 2 negatives makes a positive. 1 over 1 is 1. That is number 24. Integral e to infinity 1 over x times natural log of x the whole square dx. Again, substitution. Natural log of x is equal to u. So differentiate 1 over x dx is equal to du. So it becomes 1 over x is du. 1 over x dx is du. And 1 over u square. Yeah, that is u to the negative 2, which is u to the negative 1 over negative 1. X varies from e to infinity, and u is the same as natural log of x. So negative 1 over natural log of x. E to infinity, substitute the limit, negative 1 over natural log of infinity minus negative 1 over natural log of e. Natural log of infinity is infinity, so 1 over infinity is 0. Natural log of 1, e is 1, so two negatives makes a positive. So that is 0 plus 1. The answer is 1. Number 26. Yeah, that question is a little difficult. Integral 1 to infinity dx over square root of x plus x times square root of x. You may pull out a square root of x. So that is integral 1 to infinity square root of x times 1 plus x. Let square root of x is equal to u. So x is equal to u square. Dx is equal to 2u du. So this becomes integral x varies from 1 to infinity 2u du divided by u times 1 plus x. X is u square. So 2u du divided by u times 1 plus u square. U cancels. It becomes 2 times integral 1 over 1 plus u square du. And a derivative of 1 over 1 plus u square is tan inverse u. So this is 2 times tan inverse u. X varies from 1 to infinity. And so that is 2 times tan inverse square root of x 1 to infinity. And so 2 times tan inverse infinity minus tan inverse 1. Tan inverse infinity is pi over 2. So that is 2 times pi over 2 minus pi over 4. Tan inverse 1 is pi over 4. That is, distribute the 2 pi minus pi over 2, which is pi over 2. Question number 28. Integral 0 to 5, 1 over cube root of 5 minus x dx. So this is equal to integral 0 to infinity 5 minus x to the power of negative 1/3 dx. That is equal to 5 minus x to the power of 2/3 negative 1/3 plus 1 divided by 2/3. So 5 minus x to the negative 2/3 over 2/3 times 1 over negative 1, because coefficient of x is negative 1. Now substitute the limit and you get 2 negative 3/2 times this negative sign becomes negative 3/2 times 5 minus x to the 2/3 from 0 to 5. That is negative 3/2 times. When you substitute 5, it becomes 5 minus 5, which is 0. When you substitute 0, you get 5 minus 0, that's 5 to the 2/3, and that is equal to 3 over 2 times 5 to the 2/3, because 2 negatives makes a positive. So that integral is convergent, and this is an improper integral because there is a vertical asymptote at x is equal to 5. There is a vertical asymptote at x is equal to 5. Therefore, that's an improper integral, but that integral is convergent. Number 30. Integral negative 1 to 2 x over x plus 1 the whole square dx. This one has a vertical asymptote at x is equal to negative 1. So let x plus 1 is equal to u. So x is equal to u minus 1. Dx is equal to du. So x is u minus 1. That is going to be u minus 1 over u square du. Split it. Integral x varies from -1 to 2, 1 over u minus 1 over u square du. Antiderivative of 1 over u is natural log u, and that of 1 over u square is -1 over u. You have seen that integral several times. X varies from -1 to 2. So that is natural log of x plus 1 divided by, natural log of x plus 1, absolute value of x plus 1 plus 1 over x plus 1. When you substitute x is equal to -1, you get x plus 1 becomes 0 in the denominator, which is infinity. So this final answer is -infinity. Therefore, the integral is divergent. This 1 over 0 makes it divergent. Integral 0 to 1 dx over square root of 1 minus x squared. This also is an improper integral because there's a vertical asymptote at x is equal to 1. But you have direct formula. This is sine inverse x from 0 to 1. That is sine inverse 1 minus sine inverse 0, which is pi over 2. Number 0 to 5, w divided by w minus 2 dw. The function has a vertical asymptote at w is equal to 2. So we split the integral as 0 to 2 w over w minus 2 dw plus integral 2 to 5 w over w minus 2 dw. So first one, we are calculating the first one. You add and subtract and add a 2 at the top. So it becomes integral w minus 2 over w minus 2 is a 1. So 1 plus 2 over w minus 2 dw, and that is w plus 2 times natural log of w minus 2. When you substitute a 2 there, you get 2 times 2 natural log 0. Natural log 0 is -infinity, and so the answer is -infinity. One branch diverges, so the whole thing is divergent. Number 36. Zero to 4 dx over x square minus x minus 2. First you factor the denominator. 1 over x square minus x minus 2 is 1 over x minus 2 times x plus 1. Write it as a over x minus 2 plus b over x plus 1. And multiply by the LCD, you get 1 is equal to a times x plus 1 plus b times x minus 2. That is 1 is equal to ax plus a plus bx minus 2b. And that is a plus b times x, a plus a minus 2b. So a plus b is 0 because there is no x in the left. Minus a minus 2b is equal to 1. A minus 2b is equal to 1. You multiply by a -1 and then you add these two. A cancels. You get 3b is -1. So there is a mistake there. So 3b is equal to -1. Therefore, b is equal to -1/3 and a is +1/3. So these two numbers are different. So please correct that. A is -1/3 and b is a is +1/3 and b is -1/3. There is a mistake here. I'm sorry about that. So a divided by x minus 2 means 1 divided by 1 over 3 natural log of x minus 2 minus 1/3 natural log of x plus 1. Anyhow, the integral is divergent because there is a natural log of x minus 2 is there. Of course, this term is positive and this term is negative. It doesn't matter. When you substitute a 2 there, you get x, natural log of x minus 2 becomes natural log of 0, which is negative infinity. So this is divergence. Please notice this mistake, but that does not affect the answer. So the answer is that integral is divergent. Please note a, when you subtract, 1 becomes negative. So 3b is negative 1. B is negative 1/3, A is positive 1/3, but when you substitute the limit, you get natural log of 0 somewhere, so that is divergent. Next, just check whether these are convergent or divergent. Integral 1 to infinity 1 plus sine square x over square root of x. And we know sine square x is greater than or equal to 0. We are going to apply the comparison test. So sin x is between negative 1 and 1, means sine square x is greater than or equal to 0. So 1 plus sine square x is greater than or equal to 1. Therefore, 1 plus sine square x over square root of x is greater than or equal to 1 over square root of x. Therefore, integral 1 to infinity 1 plus sine square x over square root of x dx is greater than or equal to integral 1 to infinity 1 over square root of x dx. 1 over square root of x means x to the 1 over x to the 1 half. 1 half is less than 1. Therefore, the right side is divergent by p test. This right side is divergent. Therefore, left side is greater than a divergent. That means left side is again divergent. So if right side is divergent, then the left side is divergent. This is the p test. So you use the comparison test and the p test. That is because of the presence of sine square x or cos square x or sin x or cos x. In most of those cases, comparison test will help you. Then number 52. And we know 2 plus e to the x, that's the denominator, is greater than e to the x. Therefore, 1 over 2 plus e to the x is less than 1 over e to the x. And also tan inverse x is less than pi over 2. Because pi over 2 is the maximum value. The range of tan inverse x is from negative pi over 2 to pi over 2. So we are going to use these two principles. So tan inverse x is less than or equal to pi over 2. 1 over 2 plus x is less than or equal to 2 plus e to the x. So the tan inverse x over 2 plus e to the x is less than or equal to pi over 2 times e to the negative x. Pi over 2 times e to the negative x, and therefore you evaluate this integral. Right side is convergent because e to pi over 2 times e to the negative x over negative 1 from 0 to infinity, that is negative pi over 2 times e to the negative infinity minus e to the 0. E to the negative infinity is 0. So final answer here is pi over 2. Right side is convergent, therefore left side converges because that whole expression is less than or equal to that pi over 2 times e to the negative x. Okay, that's all about that section. Yeah.